So section 4.3, we're going to discuss yet another way you can solve systems equations. So far we have two. We've got the substitution method and we've got graphing. Of course, graphing has some really serious drawbacks, not the least of which is that it's very time consuming, labor intensive, etc. And if your answers aren't nice integer numbers, then good luck in finding it. So we're going to work on something called the addition method. And the addition method kind of lives up to its name because what it allows you to do is add equations or multiples of equations together. So what would happen if I added these two equations together? What would I get? 2x equals 12. And I want you to notice something that happened when I added these two together that was very nice. I got rid of the y's, right? You had two terms that had opposite signs. Same coefficients, but opposite signs. -1 and 1. And when you added those together, they canceled. So if 2x equals 12, what does x equal? 6. Wow. We're like almost done. If x equals 6, let me substitute that in here. 6 plus y equals 8. What does y equal? 2. Am I wrong or are we done? That's it. 6 and 2.
That was easy.
Yes. That was nice. That worked out pretty good. So, Patricia, something bothering you on this one. What? Where did I get the 2? I subtracted 6 from both sides. Yeah, thank you. That's it. Now, they're not always going to work out so easily, but notice what made this work. When you added these two together, they had the same coefficients but opposite signs, and that canceled out one of the variables. So that was really, really helpful. Let's see that again with problem number 18, kind of another of the warm-up variety. -9x plus 5y equals -9, and then -9x minus 5y equals -9 again. Now let's stop and think for a second. There's other ways you could solve this. You could solve this by substitution, right? But that'd be a real pain. Can you imagine having to solve for y and then plug that expression, which involves fractions and other junk, into the other equation and then manipulate it? Ugh. Instead, what would I get if I added these two equations together? Nick, what would I get here? Yeah, -18x equals -18. Great. So what do I have to do to solve for x? Divide by -18, so x equals 1. If x equals 1, I still have to figure out what y is. And be careful on your exams that when you solve a system of equations, you don't just stop here. You will lose points. Okay? You need to give me both solutions. So let's come back up here, substitute in x equal 1 into, say, the first equation. -9 times 1 plus 5y equals -9. And solve for y. Elizabeth, what should I do to solve for y here? Add 9 to both sides. Good. 5y equals 0. What does y equal? Y equals 0. Great. So there's x and y. Great question. No, it does not. If you plug into the top or bottom equation, you should still get the same thing for y. So my rule of thumb is choose whichever one is easier. If you notice, in the first equation, I chose this one. So I didn't have to worry about a negative. I could have substituted x equals 6 into the first equation. 6 minus y equals 4. Subtract 6 from both sides and get minus y equals -2. But then I got to divide by -1. And guess what? I still end up with y equals 2. So my suggestion to you is you pick whatever equation looks easiest. Okay? If I graph this, and I don't want to graph it by hand, but if I graphed it using some software, would these equations, would the graphs cross each other? If I graphed them simultaneously, yeah. So they would cross each other. Where at, Madison? Where would they cross each other? Yeah, at the point 1, 0. Point 1, 0 is your solution to the system equations. So that's the point where they're going to cross each other. It's a consistent, independent system of equations. And you can kind of imagine that they're not all going to work out nice and even like this. The message you should be getting, though, is how these things cancel. When we add 5 plus -5, you get 0. So that term drops out. In order to work these things by the addition method, you're going to have to engineer this kind of thing to happen. That you have something and its opposite that are getting added together. So let's move on to problem number 22. X plus 7y equals -22, and x plus 9y equals -24. Let's take a careful look at these. If I add them together, is anything going to cancel out? No. In order for the addition method to work, you need to get rid of one variable. And that's not happening. So I'll tell you what we're going to do is we're going to multiply one of these equations by something to help this out. I want this kind of a situation. I want two variables to cancel each other out. What could I multiply by so that I can get that to happen? Yeah. Let's multiply by -1. These two terms have the same coefficient. I just want them to have opposite signs. So -x minus 7y equals 22 added to x plus 9y equals -24. When I add these together, Autumn, what do I get? All right, so 2y equals -2, divide both sides, and we get y equals -1. Cool. Madeline, what do I need to do? What should I do to solve for x? Yeah. Plug y into which equation? Which one do you want to plug it into? First one. Sure. Brian? I tend to, my habit is I always tend to go back to one of the original equations. But yeah, you could plug it in here. That'd be fine. I'm just going to go back to the first equation. It's going to be x plus 7 times -1 equals -22. So x minus 7 equals -22. If I add 7 to both sides, I get x is -15. Yay! X is -15. Overall, -15 and 1 would be what you would see in the back of the book. Consistent, independent, and this is where the two lines would cross if you took the time to graph them. Okay, let's do maybe one or two more, and we'll call it a day. So that was 22. Let's take a look at problem number 26. Tell you what, let me throw out a little carrot for you guys. If you guys can help me work through this, then we make this the last problem. Sound good? Okay. I like that. All right, I'm pushing the right buttons. 5x minus 14y minus 32 equals 0. 5x minus 14y minus 32 equals 0. And then negative x equals 6y plus 20. Now on your exam, I'm not going to tell you what method to solve here. You know, and if you were facing this on an exam, I think an easy way to solve this would be substitution, right? Just divide everything through by -1 on the second equation, and you have x equals something, substitute it in here, and be done. But I want to practice the addition method here. In order to use the addition method, one thing has to be true is this. The x's and y's and the constants have to line up. So let's start there. I'm going to try and get this in this form. ax plus by equals c. I want that for both equations. What do I have to do here? For the first equation, to make it look like this. Add 32. So I end up with 5x minus 14y equals 32. What do I have to do with the second equation to put it in that form, where I've got my x's and y's on one side, the constant on the other side? Ed? What do I have to do to make this equation look a little bit more like this or this? All right, subtract 6y from both sides. And end up with negative x minus 6y equals 20. Thank you. 5x minus 14y equals 32. Negative x minus 6y equals 20. Can I add these together? Mariana, can I add these together and have everything cancel out like it should? No. So I need to work with it a little bit. Almost there. What do I need to do so I can get these things to cancel each other out? Good. If you multiply the bottom equation by 5, let's see what happens. The top equation stays the same. I have 5x minus 14y equals 32. The bottom equation becomes minus 5x minus 30y equals 100. Now we can add these things together. I get negative 44y equals 132. You can take out your calculators and find that y equals negative 3. Brian, you were asking earlier about, can I go to an intermediate equation to solve for the other variable? Sure. If you wanted to, we could go right up here to solve for x. And I'm choosing that because it's conveniently on the screen that you can see here. So it's negative x minus 6 times negative 3 equals 20. So negative x plus 18 equals 20. Subtract 18 from both sides. Negative x equals 2. So x equals negative 2. Nice. So consistent, independent, and your solution is negative 2 and negative 3. Consistent / independent. Great. For homework, we'll keep it simple on you. Try 13 through 27. Wow, that's like 7 or 8 problems. Which one? Okay. Have a great weekend. Yeah, Jalen? Good question. Why did I multiply by 5 here? Because if I had a 5 and a negative 5, when those add together, they add to a 0. They cancel each other out. So I have to make that kind of a thing happen. And sometimes I have to multiply one of these equations by something in order for that to happen. I could have done it with the y's, but it would have been a lot harder to get these to cancel each other out. Because I need something that is evenly divisible by 14 and something evenly divisible by 6. You always want them to be the same, but opposite in sign. So the 5 and negative 5, or 3 and negative 3, that kind of thing. What? I did.